Now in the previous lecture, we have learned and performed operations for a cube in which we don't have fixed capacity. This means that we can insert as many as elements in the cube, and after some time this becomes very time-consuming data structure. Because when we append the list, memory reallocation occurs, which causes performance leaks. And also, when we remove the first element from the list, all rest elements have to shift one step left, and this is very time-consuming operation. So to solve these problems, we have another option, which is to create a circular queue using fixed size list. In this case, the problem of moving elements to the left and reallocating the list as it grows is solved. By using fixed capacity for a cube, we can create a circular queue which performs very fast. In this case, we don't have to shift elements left and the memory reallocation will not occur. So let's see how it works. So the first operation will be to create a queue. So the first operation over here is to create a circular queue. In this case, we create a blank list with fixed size and we create two variables, top and start variables, and we set them -1. We know that in Python, to create a blank list with a fixed size, we need to set all elements of list to none. So here we have created a queue with the size of 6. So as you see, we have 6 elements in the list and we have set all elements to none. So now we have an empty queue like this. And we know that if we enqueue an element to this queue, it will start from the first element, and every time when the new element comes, it will locate it after the first element over here. So let's see how enqueue and dequeue works in the case of circular queue. So in this case, when we enqueue the first element to this queue over here, we need to update start and top variables as well. So in this case, start and top variables points to the first element over here because we have only one element in the queue. So then when we insert the second element, the top variable gets updated, but the start property remains the same. So if we call enqueue method one more time for 6, you will see that 6 will be added here and the top value will set the element over here. So as you see, the top variable is changed to 1. Now if we run enqueue method one more time, the top property will change to 2 and it will set to here. So it will continue like this until we reach the end. Now in this case, we have reached the end and our queue is full. Now let's see if we perform dequeue method for this queue over here. And what will happen in this case? Now if we dequeue an element from this queue, the first element will be returned. And we know that first element in our case is the 5 because start variable points to this element over here. And in this case, we will not remove the element from the list, we will just ignore it. So to ignore it, we are just setting the start variable to 1. So in this case, we are ignoring the first element over here. Now our first element in our queue is 6. So if we run the queue method one more time, it will return 6 because our start property points to the 6 now. And it will ignore the 6 and will move to the next element over here. Now you might be interested, in this case, if we call enqueue method now, what will happen? Because now our top property points to the last element over here, so it might show that this is full. But in this case, it works differently. So if we call enqueue method for the element of 9, we will set top to 0 because here we have empty cell over here. So the top will be 0 and this new element will be inserted over here. And it continues like this. If we call enqueue method one more time, it will insert here and top will be point over here. Now, when the top reach over here, it will show that this circular queue is full. So we cannot insert an element over here. So here we have learned that whenever we call enqueue method, we are changing the place of the top variable, but whenever we call dequeue method, we are just updating the start property of this queue over here. So by doing this, we are preventing to remove element from the first of the list over here, which prevents moving of elements to the left. And we are not adding the element at the end of list, and this prevents the relocation of the list. Now the next method is pick method. So in this case, pick method always returns the first element. So it will return the element based on this start property over here. So if the start property says 0, it means that we will return the first element from this list. So in our case, it will be 5. Now let's imagine that we have a case like this. So what will happen if we run pick method like this? So in this case, one more time, we see that start property of this queue points to the element which index is 1. So we will ignore the first element from here and we will return this element from here. This means that if we run pick method for this queue over here, it will return 6 because in this case our first element in the queue is 6. Now the next method is full method. So if start property points to 0 and top property points to the last element, it means that our queue is full. So we will return true because in this case it is full. So there might be cases that the top points to here and start points to the over here. In this case also we are checking if there is an empty cell in this list, then we are returning false. If there is not, then we are returning true, saying that this queue is full. Now if we run the full method for this case, we will see that it returns false because in this case we have blank cell over here. So in this case it returns false. Now the next method is empty method. So empty method checks that if this list is empty or not. So if this is empty, it returns true. If this is not empty, it returns false. In this case, it will return false because here we have elements over here. Even though we have one blank cell, it doesn't mean that it's empty. Finally, the last method is delete method. We know that delete method in case of queue is responsible for deleting all elements from the queue. So in this case, we are just setting this list to none. So in this case, all elements will be none and the start and top properties of this queue will be set to -1. Now with this, we have completed this lecture. Now in the next lecture, let's create circular queue based on Python list in practice. So see you in the next lecture.